Hey students, today's lesson is on angles of polygons. To start with, let's go ahead and get some key vocabulary. So a polygon is a closed, plane figure made up of 3 or more line segments that intersect only at their endpoints. So here's some examples of polygons. These would be examples that are not polygons. So these are not made up of line segments. We have some different arches here. And this last one, the orange one, intersects at somewhere other than an endpoint, so therefore that is not a polygon. A regular polygon is a polygon in which all sides are congruent and all interior angles are congruent. So a square would be an example of a regular polygon, as would an equilateral triangle, but we can see polygons of all numbers of sizes that are regular polygons as long as all sides and angles are congruent. Now, one more key idea to get us started. The sum of the interior angle measures of a polygon within sides would be n minus 2 times 180. So we already know that the sum of the angles, the interior angles of a triangle is 180. So we could kind of test this out to say, well, 3 minus 2 is 1. 1 times 180 is 180. But it's going to be true for all polygons that we can use this formula. So let's go ahead and look at this first example. So we want to find the sum of the interior angle measures of the school crossing sign. Doesn't matter that it's not a regular polygon. We have a pentagon here with different angles. We have some that are 90 degrees, some that are larger than 90, some that are smaller than 90. But the sum of the angles should be n minus 2 times 180. So in this case, our sum is going to be 5 minus 2 times 180, which is 3 times 180, or 540. Okay? Let's look at our next example where we're finding an interior angle measure of a polygon. So here we're given all of these angles, and we have one angle that's x that we need to solve for. So first we need to figure out, well, how many degrees are there in the sum of the interior angle measures of this polygon? So it has 1, 2, 3, 4, 5, 6, 7 sides. So we're first going to say S equals 7 minus 2 times 180. That would be 5 times 180, which is 900. So the sum of all of these angles is going to be 900. So we can go ahead and add up 128 plus 130 plus 120 plus 115 plus 145 plus 140 plus x, and all of those together are going to equal 900. All right, when we add all of those up, we get 778. So we're going to say 778 plus x equals 900. And then we can solve for x by subtracting 778 from both sides. And we get x equals, 122. So that's a 122 degree angle. All right, here's another example. We have this real-life application that this cloud system discovered on Saturn is the approximate shape of a regular hexagon. So we can see sort of this regular hexagon here. Obviously, we can't see it in the actual shape, but it's blown up to show us this. Find the measure of each interior angle of the hexagon. So in this case, we're going to find the total degrees if we add up all of the angles, and then we'll have to divide by 6. So here we have 6 minus 2 times 180. That's 4 times 180, or 720. So the total, all of the angles together add up to 720. And now we'll just take 720 and divide by 6 because we know they all have the same measure. So 6 goes into 7 once. All right, so each of these angles is 120 degrees. All right, let's look at another key idea here. So the sum of the measures of the exterior angles of a convex polygon is 360 degrees. So regardless of what kind of polygon it is, whether it's a triangle or a square or a pentagon or an octagon, the sum of the exterior angles is going to be 360. So let's take a look at that. So here we have some exterior angles. Remember, those are formed when we extend one of the side lengths. So here we have an exterior angle of 127, 50, 91, and then x. So we need to go ahead and add up all of these exterior angles, and they should add to 360. So here we're going to say 50 plus 127 plus 91 plus x equals 360. We can simplify that. That's 268 plus x equals 360. We'll subtract 268 from both sides. And we get x equals 92. So this angle here is 92 degrees. Let's do the same thing for this triangle. This time we're going to say z plus 26 plus 124 equals 360. And then we can combine our like terms to get 2z plus 150 equals 360. And now we're going to subtract 150 from both sides. We get 2z equals 210. So then to solve for z, we divide by 2 on both sides and get z equals 105 degrees. Okay, and then let's see, find the measure of each exterior angle. So if we go back and look, this exterior angle is 105 degrees, but then, and this one's 124. We need to still find this one. So this is 105 plus 26, so that would be 131 degrees for this last exterior angle. All right, so go ahead and try a few on your own, and I will see you soon.